y'all, cause this is it. The numbers we're making are so vicious. Mathematicious, expeditious can be kinda scary. I hope my answers are radical or imaginary. I convert percents to fractions. It brings me some satisfaction, like scientific notation and order of operations. Mathematicious, it's me expeditious. My answers make it vicious. My erasers often stitches. I make wishes. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicious. Mathematicious.
Find time news for me.
Mathematicious.
Or I'll use trigonometry.
I'm mathematicious.
Decimal.
Hey everybody, alright, just a little mathematicious song to get us started off. We're looking at 7.4, adding and subtracting rational expressions. So we're going to be adding and subtracting, we're going to be rewriting some rational expressions. We're going to be simplifying complex fractions as well. We'll look at those at the very end. Alright, a little quick cartoon, a little Far Side cartoon to start us off. So there's a couple of deer in the woods. One guy says, yeah, they're a bummer of a birthmark, Al. Oh, I love that one. Alright, here we go. Core concept. Adding, subtracting with like denominators is the first one. So you know this. We know when we add and subtract fractions, we are going to make sure we have a common denominator. And if we already have one, then all we have to do is add numerators, but keep the denominator the same, or subtract numerators and keep the denominator the same. So this first few problems here, 1 through 4 in the extra practice, will actually go pretty quick and be pretty easy because they'll just be all like denominators. Okay, so here on page 208, there in our notes, extra practice 1 through 4, just find the sum or difference. You'll notice all 4 of these already have like denominators on every single one. So all we have to do is just either add the numerators or subtract them. So number 1, we're subtracting 1 minus 5. So we'll just do 1 minus 5 is going to be over x minus 1, and 1 minus 5 is just negative 4. So that's our answer, negative 4 over x minus 1. Very simple. Number 2, we're going to add the numerators this time, which would be always combined like terms if we have them. So we're going to see 4x plus x over the common denominator of 3x minus 5. And when we add 4x, we can combine these like terms here. That will become 5x. So now our answer is just going to say 5x over 3x minus 5. Now remember, you cannot cross out this x and that x because this is a monomial and that is a binomial. You can't do that. Coming down to number 3, we're going to add numerators here, 6x plus 24, but those are not like terms, so we can't put them together. It's over the common denominator of x plus 4. But what we can do on this one is we can factor out a common factor here because 6 goes into 24. So I can factor out a 6 in this numerator, and then what would be left here, if I take 6 out of this first one, we're just going to see x here, and then 24 divided by 6 will be 4, so we'll see an x plus 4. Then binomial, so 6 times x plus 4 is over x plus 4, and now we have a matching binomial. Now we're going to go ahead and just cross those out. So cancel out matching binomials. The only thing that's left is 6 over 1, so our answer then is just 6. However, we do need to remember about the excluded values. So we did have an excluded value here in the problem. We know that x cannot be negative 4, and since we canceled it out, it's not a part of our answer. We canceled it out. We have to say that x cannot equal 4 for this problem in our answer. So that's a part of the answer, is stating that x can't equal negative 4. Okay, going on to number 4, we're going to subtract the 2x squared minus the 14x. Again, those are not like terms, but then they're going to be over x minus 7, the common denominator. We can factor again here as well. So we have a 2 and it goes into 14. So we can factor out a 2, and we have 1x that also can come out. So 2x can be factored out of this. And so I factored 2x out of our first one. The only thing left will be an x in the first part of this binomial, minus the x is gone, but now 14 divided by 2 would be 7. So we're going to see an x minus 7. binomial inside there, and it's over x minus 7, so there's a matching binomial again. So matching binomials can cross-cancel, so we can cross-cancel those x minus 7s. So that means the only thing left is 2x. 2x is over 1, which we can just say the answer is 2x. But again, this one has an excluded value because there is an x at the bottom here, and so we have to state this one, that x cannot be 7, otherwise it makes this denominator 0, and we canceled that one out, so it's not in our answer. So we need to state the fact that x cannot equal 7 on this problem. You might be saying, why didn't we state the excluded values on these top two? Well, it's because the only excluded value in this problem was that x can't equal 1, and it's still in the answer. So you can see in the answer here that you have an x minus 1 binomial, and you can see from the answer it's clear that x obviously can't be 1 in this one. This one, it would be actually a fraction like 5/3. X can't be 5/3 in this one. So we don't have to say that because it's still in the answer. Okay, our next core concept now is talking about adding and subtracting with unlike denominators. So now we have to find a common denominator. And finding a common denominator is like an LCD, a least common denominator. It's the same thing as finding the least common multiple of the denominators. So let's talk about LCM first, because that's what we're going to do next on these next few problems. LCM, least common multiple, that's what that stands for. You can go and write that down here. LCM stands for least common multiple. And when we're dealing with the expressions here, these kind of polynomial expressions, it's easiest to kind of think about this. For instead of saying least common multiple, we'll do a different kind of acronym for LCM. So I'm going to say let's count most. Let's count most for LCM. That's really going to be more helpful for us as we're trying to find what the common denominator is. So obviously when we're adding and subtracting, we have to find a common denominator first between the denominators, and then we can make equal fractions. So there's like kind of like 3 steps here. Find the common denominator, LCD, the common denominator, then make equal fractions here next, and then we add or subtract the numerators and keep that common denominator at the bottom. And always the last thing to do would be to simplify or reduce your fractions at the end. Okay, so let's go ahead and try these next few extra practice on LCM. Okay, so 5, 6, and 7 just say find the least common multiple. So basically we want to kind of pretend these are like the denominators of our fractions, and so when we're trying to find the common denominator, this is what we do. And it is finding the least common multiple of the denominators, and so we're going to count most here for these. So starting with number 5, we have a monomial here first, and then this is a binomial, so these are like our 2 different denominators. So on this one, 9, what we can do here is we're going to count most. Let's kind of put that into prime factor form. So that's the same thing as saying 3 squared for 9, and then you have your x to the third. For this one, we want to factor out a common factor. 3 can go into 21, so we can factor out 3. We also can factor out 1x. So that's going to be a 3x then coming out. And what's left here from our first part would just be 1x, the minus sign, and then 27 divided by 3 would be 7. So that's going to be an x minus 7 binomial with what's left inside. And if you multiply back with the distributive property, you get back to here. That's how you can always check that. So now you want to count most. Now that we see everything here kind of in factored form, and that's what you want to start with first, make sure it's all in prime factored form, and then you can see about counting most. So we have, as far as the 3's go here, we have 1 3 here on this one, on this monomial, and 2 of them here. So we want to have 2 in our LCM. So what's the LCM going to start with? It's going to start with 2 3's. And then as far as the x's, we have 1x here in this monomial. We have 3 x's here, so we want those 3 x's to be also in there. That's the most of them. And then as far as the binomial, this one has an x minus 7 binomial. This doesn't even have 1 at all, so the most of the x minus 7's is just one of those. So we're going to include an x minus 7 binomial. So this one has kind of 3 parts to the LCM. The number with the 3, the x's, for the monomials, and then your binomial here as well. So the other thing to do here, just make this back to 9. Just turn it back into a 9. And so we can say 9x to the third times x minus 7. That's our LCM right there. So that would be the LCM, or even the common denominator, we can think of it as. Number 6. So our first one here just says x plus 5. That's already in prime form there. The next one, though, is a trinomial, which we would need to get into prime factored form. So we need to factor this into 2 binomials. So like I said, the first one's already prime, so we can list that one there. But then as far as the second one, we're going to need to do the star method on this one because it's got a 2 in front. So it's not the simple method. This would take the star method. Remember the star method, you're going to multiply 2 times 5, the first number times the last number. That's going to give you a positive 10 for the top on the star. The middle number here, positive 11, goes at the bottom of the star. And then the top 2 sides here is just the way this begins, with the number and the variable, 2x. So 2x is going to go on the top of both sides. And then you're asking yourself, what 2 numbers multiply to give you 10 that will add to give you an 11? So that's going to be 10 and 1. And they're both the same sign. They're both going to be positive with this positive 11. So 10 and 1, they multiply to give you 10. 10 and 1 add together to give you a positive 11. And now you want to see, can you simplify the sides? So right here, 2 and 10 can reduce by 2. So 2 can become a 1 and 10 can become a 5. And so now we can see what our 2 binomials are going to be. We're going to get an x plus 5 on this one, and then a 2x plus 1 for that one. So here's our 2 binomials. X plus 5 is the first one there, 2x plus 1. It doesn't matter the order those 2 are in, but those are the 2 binomials that this factors to. So now as we start to build our LCM, now that everything's in the factored form, we can count most. So they both have 1x plus 5. So that's got to be in, they both have an equal amount of those. So you're just going to include one of them. And then this one has a 2x plus 1 that this one doesn't have. So you got to still include this 2x plus 1. Even though this one doesn't have it, this one has the most of those. So you want to think, okay, the most of the x plus 5s is just 1 in each one. And the most of the 2x plus 1s is also 1 just from this one here. So our LCM, or our common denominator, is going to be those 2 binomials. Number 7. So number 7, we have 2 trinomials that we have to factor. They're both going to be just simple method factoring. So our first one here, it starts off with x and x. What 2 numbers multiply to give you 6, that add to give you 5. So that's going to be just 3 and 2. So our first one's going to be x plus 2, x plus 3. They're both the same sign. They're both going to be positive, so they're both positive in there. This next one over here, we're going to see that, again, x and x up front. What 2 numbers multiply to give you 18, that subtract to give you 3. And so it's going to be 6 and 3. So we're going to see x minus 6 and x plus 3, because they're different signs with the negative 18. The bigger one's going to be negative, so 6 gets the negative and 3 gets the positive. And so now as we start to build our LCM, let's look at how many different binomials do we have here. We have an x plus 2, an x plus 3, and an x minus 6. So how many, the most of the x plus 2's is just 1 seen anywhere. So we're going to include an x plus 2. The most of the x plus 3's is just 1 seen anywhere in each one. Even though we see 2 of them, but there's only 1 in this one and there's only 1 here, so the most is still just 1. And then the most of the x minus 6's is just 1 seen over here on this one. So all 3 binomials on this one are the LCM. This would be the common denominator of our fractions if we were doing the fractions. So that's our LCM on that one. Remember, let's count most. Remember, write that down. So you remember, you're just counting the most of each thing to put into the LCM. Okay, so we're back on 209 for finding the sum and the difference now. So now we're looking at the actual fractions. We're adding and subtracting our fractions with the unlike denominators. So that's the first thing we need to do. Remember, there's basically 3 steps here, and you may want to write these down also kind of on the side, or you can actually write this down in your notes perhaps on maybe just go back to page 207. So let's do that. Okay, so I wanted you to put down on page 207, just at the very bottom where that little note section is, let's just write down the 3 steps there for adding, subtracting with unlike denominators underneath that little core concept. So again, step 1 would be to find your LCD, that common denominator. So we're finding LCD, which is the same as the LCM of the denominators. So least common denominator, we're going to do it the same way as our LCM. And then once we find that and figure that out, well, then we have to make equal fractions. Make equal fractions. Oops, not that. Make equal fractions using the LCD. And then number 3 then would just be, again, add or subtract now our numerators. And you're only adding and subtracting numerators, not the denominators. So just make sure you put those 3 steps down there so we know as we're going through these next few problems, this is what we're going to go off of. Okay, so let's go ahead and start with number 8. So step number 1, common denominator between 2x and 5x, and we're kind of thinking of our LCM as well. What's our least common multiple of these two? So you can think, well, it has to have a 2. So the most 2's there are is 1, 2. The most 5's there are is 1, 5, and the most x's there are is just an x, 1 x in each one. So there's only 1 x, that's the most. And so if we combine all that together, that's going to become 10x. That has to be what our common denominator is going to be, 10x underneath each one of these. And so now we have to figure out what do we need to multiply the numerators by to make equal fractions. That's our step number 2, using our common denominator. So what did we multiply this 2x by to get a 10x? Well, we multiplied it by 5. So we're going to have to multiply 3 times 5 here, which would give us 15. And then this one we multiplied the 5x times 2, so we're going to have to multiply the 11 times 2, making 22. And so now when we add the numerators, 15 plus 22, we'll get our answer here. So that's going to give us 37 over 10x. And if we could simplify 37 and 10, we would, but we can't. So that's our answer then for this guy right here. We don't need to say anything about excluded values. The only excluded value in here would be that x can't be 0, and it is already still in our answer here. X can't be 0 even in our answer. Okay, going over to number 9, we have 2 binomials. So what our LCD here is, I'm just going to go over here and put it down. So what the, make one big long fraction. So we have 2 binomials. The most of the x minus 2's, there's only one of those, there's only one of these, so we're just going to put them next to each other. So the most of each one is there's only one of each. So there's our LCD. So what do we multiply this one by to get this? It's just we're multiplying it by the other one. So this is going to, 15 is going to get multiplied by the x plus 8 right there. And so when I multiply that with the distributive property, 15 times x will give me a 15x. 15 times 8, if you want to try that here, just 15 times 8. That's going to give us 120, so plus 120. And then over here for the 3, we're going to multiply it by our x minus 2. So 3 times x would be positive 3x, and 3 times negative 2 is negative 6. So now we need to combine like terms in the numerator as we start to add these together. So 15x and 3x, that makes 18x. So this is going to have an 18x in the numerator. We're also going to have 120 minus 6. So that's going to be a positive 114 over the 2 binomials, x minus 2 and x plus 8. So there's our 2 binomial answers. So the only thing to do maybe is to see if I factored out something here, could I get one of these binomials? And we're not going to be able to do that, because in order to do that we would have to get just an x here, which means 18 would have to go into 114. And you can try that just to make sure. Oops, too many ones there. So 18, see if it goes into this 114. So divided by 18, and it does not go in evenly. So there's no way to get one of these binomials up on top. So that just means we can just keep this as our answer. So there are two excluded values, but those two values are still in the answer here. We see x can't be 2, x can't be negative 8, so we don't actually have to state anything about excluded values. They are in the answer. It's only when you cancel one out in the problem that isn't in the answer that you have to actually say it. Okay, come on over here to number 10. This one already has a 2x plus 1 down here, which is already prime. This one here we need to factor. We want to factor this one with the star method. So I'll come over here with our star method. The 2 and the negative 3 need to multiply to give us the top. That's going to give us a negative 6 on top. The negative 5 is going to be at the bottom. And it starts off with a 2 and an x for number and variable. That's going to go up on top of each side. And then what two numbers multiply to give us 6? Let's subtract to give us 5. That's going to be 6 and 1. They'll multiply to give us 6. They'll subtract to give us 5. They're different signs. The bigger one's negative, so 6 is negative, which means the 1's positive. And this one can cross cancel with 2. So 2 can become a 1, and the 6 can become 3. So then what this is going to become here is a 2x plus 1 from over here. And the other side's going to be a 1x, or just x minus 3 for that one. You can double check that by using FOIL to get back to this trinomial. So now as far as our LCD, what's the common denominator here? Let's go ahead and put this big fraction bar down. There is 2x plus 1 in each one, so there's going to be one of those in our LCD. There's also at least 1x minus 3 as well. So those two, basically this one is the LCD. Because this one goes into here, you can just multiply this one times the x minus 3 to get the same thing as that for a common denominator. So the only thing we have to do is multiply the 3x then times this x minus 3 to get an equal fraction. So as we make equal fractions for step 2, we're going to distribute this in here. So 3x times x is a 3x squared. 3x times negative 3 is a negative 9x. And then we're going to say plus 10 inside this. And so now we just see, okay, if this could be factorable, it's a trinomial now, 3x squared minus 9x plus 10. If that's factorable, and maybe it might be one of these factors, we could do some simplifying. So we can try that even a little bit over here, just a little star on this one. 3 times 10 is 90, that'd be a positive 90. Middle is negative 9. So are there two numbers that multiply to give us 90 that would add to give us 9? So you can try to think about all the things that would multiply to give you 90. And you can think 1 and 90, 2 and 45, 3 and 30, so far no good. 5 and 18, still not going to subtract to get 9, or add to give you 9. So nothing's actually going to work here. This is not factorable then. And so since it's not factorable, then that's going to be our answer. And we didn't do any crossing out here of any binomials, so we don't have to say anything about excluded values either. Okay, so now we come to number 11, which the first two fractions in here has just a one binomial at the bottom, so there's nothing to do there to factor those. But this third one has a trinomial. We need to factor this one to two binomials here to see what that prime factors will be. So x squared will be x and x, and just using simple methods. So two numbers that multiply to give us 7, that subtract to give us a 6. They're going to be 7 and 1. And then they're going to be different signs. The bigger one is going to be negative. So negative 7, positive 1, and that matches with these over here. We have an x minus 7 and x plus 1. So since both of these are these two over here, this actually would be the common denominator. So when we think about what's count most, the most of the x minus 7 binomials, there's just one of those, and there's only one x plus 1 binomial in any one of these three. So that's what's going to be on the bottom. The top we're going to need to multiply. So let's put down a fraction. So let's put this denominator down here. So it's going to be an x minus 7 binomial with an x plus 1. And then so now on the top we need to get equal fractions with all of these. So our first one here, our first fraction, we multiplied x minus 7 times the x plus 1 to get that. So this one's going to require us multiplying this x times an x plus 1. So x times x will be an x squared. Let's start with putting that down. and x times 1 will be an x. So we'll put that down. And then for this one here, 2, this one's going to have to multiply by an x minus 7 binomial, so times an x minus 7. Now here's the thing though, this has a minus sign in front of the fraction. We need to really see this as a minus 2 then as we distribute this in. So it may be helpful for you to always change the minus ones to plus and then make the number up there, or term up there, negative. So now we can see it's negative 2 times x is going to be negative 2x. Negative 2 times negative 7 is positive 14. And I'm going to need a little more space here. And so now our last one here is really just a minus 8x. We don't need to multiply this by anything because it already has the 2 binomials that are in our common denominator. So it's just going to be a minus the 8x here at the end. And so now we want to combine any like terms that we see on this. So now let's go ahead and combine them. So x squared is only one of those. So it's just going to have an x squared. X is, there's an x, a negative 2x, negative 8. So it's negative 10, take away 1, it's negative 9. So negative 9x, and then you have a positive 14. And this is all going to be over our common denominator, x minus 7 and x plus 1. So now we just need to see, can we factor this numerator to 2 more binomials? That would take the simple method. Let's just check to see if we could do that. Okay, so we're going to put our x's up in front, and then 2 numbers that multiply to give us 14 that add to give us 9. So that'd be 7 and 2. And they are the same sign, and they're going to both be negative. So it does work, and it does factor out to those 2 binomials. So those 2 binomials on the top, x minus 7 and an x plus 1 is on the bottom. And so now here's what we can cross out. Cross out these matching binomials with x minus 7. So those will cancel each other out. And so then our final answer for this will say x minus 2 over x plus 1 minus 2 over x plus 1. But since we did cancel out a binomial here, and that would be one that we know that x could not be 7 for, so we have to actually say that in our answer. So we have to say x, this right here, plus, not necessarily plus, but comma, x cannot equal 7. So that's an excluded value that we canceled out in the problem. That's not in our answer anymore. This one is in our answer, negative 1. X can't be negative 1 either, but we can see it in our answer. So here's our final answer. This whole thing is our final answer there. Okay, let's take a quick second for the joke of the day. So what do you call 4 bullfighters in quicksand? 4 bullfighters in quicksand. You call them Cuatro Cinco. Okay, moving on to the last couple problems now. So you do have this core concept with simplifying complex fractions, which are these last 2 problems. And so there's method 1, method 2. I'm just going to go through one method with you where I basically work on the problem. Make sure that each numerator and each divider are one single fraction. So I just pretty much do method 1 for the most part. Simplify the numerator and denominator into one single fraction and then divide by multiplying the numerator by the reciprocal of the denominator. That's how we kind of do that. So that's what we'll do on these last 2 on 12 and 13. Okay, so for number 12 we have a complex fraction, which is a kind of a fraction problem over a fraction problem, or even just a fraction over a fraction. But in this case, we have to do each problem first. Simplify each numerator and the denominator to a single fraction. So we'll start with this one here. This 3 would be over 1, so the common denominator is going to be 10. So we know that it's going to be, so we'll put equal sign, and then our 10's at the bottom here. X is going to be still on the top of that one. And with this one, 10's on the bottom, so 10 times 3 will be 30 right there. So that's going to end up being x minus 30 over 10. So that's our top fraction right there on that one. So that's going to be our top fraction. So I'll put our 2 division bars, our bigger fractions there. And then our bottom one here has an x on the bottom, so our common denominator is going to be x. So on this fraction over here, we'll say x on this one plus an x on this one. This one stays a 1. Over here, we need to see we're going to multiply 5 times x. So this is going to just be 5x now on the top. So 5x plus 1 is a binomial here. 5x plus 1, and it is over x. So this division, or this big fraction bar, actually means to divide. So we need to realize that that means to divide the top divided by the bottom. And so we'll put down over here, so this will equal x minus 3. Now you can write the division down, or you can just say I'm going to multiply by the reciprocal here. This is this divided by this. So if I change it to times, we can now just say the reciprocal of the denominator fraction, which now is going to be x over 5x plus 1. So we can just do that real quick. That saves us a little bit of time instead of having to write the division sign down. I mean, you can. 5x plus 1 is on the bottom. And so now we can multiply across the top and across the bottom. If we could cross cancel, we would do that, but I don't see anything we can cross cancel. So on this one, it's just going to be x times x minus 3. And just keep it in factored form. You don't actually have to multiply them. And then 10 times, so 10's on the outside of 5x plus 1. So that ends up being our answer. However, is there any excluded values that we need to write that's not in our answer? So obviously there is 1 in our answer, and we can see that 1. That would actually be a fraction. It would be negative 1/5 for this one, because we would subtract 1 and divide by 5 to solve this for x if I said equal to 0. So there is 1 that used to be, so this one here, we flipped it. So this x used to be at the bottom. As you can see, it's at the bottom down here. So x cannot equal 0. That is what we need to say here. So x cannot equal 0. That's an excluded value we have to include with the answer because it's not apparent from the answer. It's no longer in the denominator anymore. X is now on the top. So that's our answer for number 12. We come to number 13. This one's a little bit bigger of a problem. So for this one, it is a single fraction on the top, but we do want to factor this out here. So we can do that first perhaps and say, well, we're going to do 12 on the top, and let's go ahead and factor this to 2 binomials. It is using the simple method, so we're just going to start with the x's up front. 2 numbers that multiply to give me 44, that subtract to give me 7. So 44 could be 4 and 11. 4 and 11 do subtract to give you that 7. So they're different signs. The bigger one is negative. So 11 is going to be negative, 4 is positive. So that's going to be over. I'll make this kind of darker here. So that's our big fraction bar, which is the division symbol. Down below here we have to find a common denominator between these 2 binomials. So the common denominator is going to be those 2 times each other. So let's put a little smaller fraction bar down here. It's going to be x minus 11 times x plus 4. That will be the common denominator, so I have to multiply this 2 times the x, basically kind of cross multiply almost, x times x plus 4 for this one. So that makes 2x when I distribute. So we'll start with 2x, and then 2 times 4 will be 8, so plus 8 there on that one. This one's going to get multiplied by our x minus 11. So 1 times that will just be x minus 11, so it'll be plus x minus 11. Alright, let's keep coming down here. So it's going to have the 12 on the top. I need to simplify this just a little bit, probably. I mean, at this point, I suppose I could change it and put it into the division. I could flip it upside down. And maybe I'll do that, actually. So we'll start with this one here on the top. So x plus 4, x minus 11. So we're going to divide by the bottom fraction, which means we need to flip the bottom fraction upside down. So multiply by reciprocal. So now our 2 binomials are on the top. And on the bottom is going to be this. But I'm going to combine like terms before I put them down here. So 2x times 1x is 3x. 8, basically if I take 8 away from negative 11, that's going to be negative 3. Okay, so now we have that. So what we can do here is we still need to factor this out. This is going to need to be factored out 3. So we'll need to factor a 3 out from that. So I'm going to have to kind of write everything down again, maybe. X plus 4, x minus 11 times, and then over here we have x minus 11, x plus 4, and I'm going to factor out this 3 now. That's the last thing I needed to do that I hadn't done yet. So we're going to say x minus 1 if I take 3 out from both of those. Okay, so now I can kind of simplify with cross canceling. X plus 4 crosses out with this x plus 4, x minus 11 crosses out with that x minus 11. The 12 and the 3 can also cross cancel, so 3 crosses out completely. 3 goes into 12 4 times, so that's going to be 4 up here. So our final answer is going to say 4 on the top, and then the only thing on the bottom is an x minus 1. And so on this one we have to include a couple excluded values that we saw, and that would definitely be negative 4 and positive 11. And so that's the only other ones, because there's only 3 excluded values that were in this problem at all, and that was the negative 4, the positive 11, and now with this one it would be a positive 1 as well. But we can see the positive 1 from the answer, so we have to include that x cannot equal negative 4 and 11. So those are the 2 excluded values for this, negative 4 and 11, and now there's our answer. Okay, so that concludes our 7.4 lesson. Go ahead and you want to continue on working on the 7.4 assignment, and then I'll see you back in class.